Okay, so good morning, guys. Today we are starting our module 15, which is related to static routing. So, what we have seen in our previous classes that we understood about networks, then we understood about IP addressing, okay, and then we understood about subnets, multiple types of networks. So, routing comes in place when you want to create communication between two different networks. See, same network communication is okay. You can communicate with the help of your switch that you put switch, you connect multiple devices and you can communicate. But as you know that we have different class of IP. Someone is using class A, someone is using class B. In class A also you belongs to different network and I belongs to different network. But as we wanted to communicate in the WAN, so different network IP or different subnets, how they could communicate together. So for communicating those different networks, we need some kind of routing. So we came with some kind of routing introduction like uh, static routing, dynamic routings. Okay, so let's have some routing protocol introduction. So as we know that okay, routing is the process which forwards the packet from one network to another network. Okay, so without routing you cannot forward the packet from one network to another network. Yes, you can forward frames from one segment to another segment with the help of switches, okay, but not packets. Packet is a layer 3 packet, frames is a layer 2 packet. Okay, frame is a layer 2 data. Now routing is used to create communication between two different unreachable networks. Okay, and it also choose the best path from routing tables to reach to destination networks. Okay, and now if you are talking about routing, so we'll have the details of routing. We have already completed this, but as I promised with some students to give some little bit review, so I'm just giving it. So suppose here I have my router and this is my network which I have two computers here. Okay, and these two computers belongs to 192.168.10.0 network and they wanted to communicate to Google, and Google is a different IP which is based on 111 something like that. And if this computer wants to communicate, so without routing you cannot send packet from this router to this router. So here you need routing, and routing can be different like a static, default, dynamic. In dynamic you can have RIP, EIGRP, OSPF. Okay, now as we already came to know that yes, we have routing and we have two types of routing: IGP, interior gateway, and exterior gateway. Interior gateway routing protocol means the routing protocol which is working inside the organization, and exterior gateway routing protocol which works outside your organization like BGP to communicate to different branches. Okay, and inside IGP we have static routing, default routing, and dynamic routing. Okay, so a static is a manual routing, default is unknown routing configuration which is used for only internet access. There will be no route manipulation, no path selection like that. Okay, dynamic routing is the best routing what people use nowadays, and in dynamic people use nowadays EIGRP and OSPF. RIP is not in use nowadays. Okay, but we will come to know RIP. Okay, because RIP is the basic understanding of dynamic routing, and once we will come to know RIP, then we will move to EIGRP and OSPF. So when we are talking about types of routing, so in that we have static routing, default routing, and dynamic routing, right? So as I told you that we are using the best one is dynamic, but for understanding we have to understand from static, default, then we will be understanding dynamic routing protocol. Okay, so what is a static routing? So static routing is also known as non-adaptive routing. Non-adaptive means it will never share any kind of information with other routers in the network. But dynamic routing is an adaptive routing which shares the information of network with other routers. But static is a manual configuration done by administrator, and the routing table, which is your one kind of map in your hand to communicate. So the map, see, so map is what? Map will help you to reach from source to destination. So same here, routing table is one kind of map of the router. So whenever you want to send any packets from the router takes the information of source to destination from the routing table, from the map. So in a static routing, so the static routing, the routing table has, you have to create manually. But in dynamic routing, it's a automatic, no need to create. Okay. So in a static routing, the routing table is created, maintained, and updated by a network administrator manually. Okay. It provide a high level control over the routing, means everything is maintained by router manually. But it will be little bit impractical when we are talking about large network. See, for a small network, you can configure something manually, right? But if it is a large network, configuring large network with the static or you can say manual configuration, that is little bit difficult for the administrator, and no one use that one. Because when we are talking about large network, okay, sometime I can consider that yes, you have configured it, but the problem will come when you will configure and there will be some kind of problem. For finding that problem, that would be a very difficult task for the administrator. Static routing default, it do not provide any kind of fault tolerance. Okay, if a single link will fail, you will never get any kind of automatic second link to reach to the destination. Okay, because it's a manual configuration, you have configured a single path, so you will have only single path to reach destination. If any changes is there in the routing table or routing domain, you have to, or like the administrator has to change manually. Nothing will be updated automatically in the routing table. When we are talking about a static routes, so if you remember that we talked about some kind of matrix. So matrix is a way to find the best path. So in matrix there is one element, or you can say one object, which is known as administrative distance. So administrative distance is used to find the, it is used to compare that which routing protocol will be the better for communication. So each and every routing protocols have administrative distance which is default given to them. If you want, you can manipulate also, but these are some default administrative distance. Okay, so for a static it is 1. Okay, and for default also it is 1. For a static also is 1, default 1, and for dynamic routing it will be a different because in dynamic we have RAY, PIGRP, and OSPF. And we will be talking about floating static routes, means it is one kind of load balancing feature in your static routing. The advantage of a static routing is that there is no overhead of the CPU, because CPU is, means like it, your CPU already know about source and destination because you have already configured in the routing table. So lookup will not take long time to find the output, because whenever your router receive any kind of packet, it's automatically hand over to the CPU, and CPU already know about the source and destination because it is already manually fitted by administrator. Bandwidth, there will be no bandwidth utilizations. Why? Because like the source connected to routers. Destination, router know already about the destinations. Okay, and as you know that the static routing is used for a small network. So in a small networks, the bandwidth utilization is not that much. Okay, if we are talking about security, okay, so yes, of course, your static routing provide, as compared to other routing protocols, static routing have their own security. Okay, means if administrator will allow you to use some gateway, like okay, the administrator wants to use this gateway, so it will use this one. If administrator wants to use this gateway, administrator can change and it can use this one. But in dynamic, it is everything is automatic. You cannot decide that okay, I should go via this one, means default. Okay, but in a static, you can manually decide that yes, this path is better and secure, so I want to go from this one. So you have to manually fit in your static routing table and you can move from that path. Disadvantages of this static routing is that if you are talking about large networks, so it is difficult task for the administrator for configuring this static routing for the large network. And if there will be a network problem or some topology problem or network down, so administrator need to have a good knowledge of TCP to troubleshoot and find where is the problem, because everything is manual routing. There is no automatic update or convergence in the static routing. Note, if connected links to the neighbor router is down, then the routes towards that gateway will be removed automatically from your routing table. So this is a practical process. Once you will see the practical, you will understand. Okay. So now we are talking about some kind of static routing configuration. Okay. So let's have some lab of this static routing, how static routing is working. Static routing lab 1. So we are going to create some lab. So let's see. So now we are going to take some routers and some switches. So here I'll be taking two router, or let's take three routers. Okay, no, first two. So I have here two routers. Okay, so here we have taken two routers. Now we are taking some switches. So we will be taking layer 2 switch. Right now we don't need layer 3 switch for this lab. Okay, now we are taking some desktop computers. So here we will be taking four, two for this network and two for. So this is our router 1, router 2. Now router is connected with switch is connected to desktop. Okay, see, the network design takes little bit time, right? Because the designs are not pre-configured. Okay, so now we are connecting the computers to switch. See, whoever will have doubt regarding the labs or initial configuration, so you can put a question and you can ask, right? Because you have to understand the initial lab. So you can say this is our first routing lab. So here you have to understand first. If you'll understand this lab, how I'm creating this lab. So when I will create the second lab, you will be understanding easily that okay, what I'm doing. Okay, so here we are going to define some networks. You see, this is a different network. This is a different network, okay? This is a different company network, and this is a different company network. Okay, so you can say this is our, you can say company A, and this is company B. Company A, company B. So when company A wants to communicate to company B, so there are some conditions. So we'll be coming to knowing about the conditions as well. So here you can say that company A is using 192.168.10.0/28 or whatever you like, 29 networks in this LAN. And here company B is using 20.0/29. Okay. So now here, whenever you want to communicate, so this is your LAN area. This is your LAN area. Okay, this is company B LAN area. This is company A LAN area. Okay, but this one is a WAN area. This one you can say this is the WAN area of company A, and this is the WAN area of company B. So inside LAN, you can use private IP address. Private IP address. Okay, here also you can use private IP address. Okay. Now, but here you have to use WAN. In WAN, you have to use public IP address. So in WAN you have to use public IP. And who will provide this public IP to you? See, the LAN private IP address you can define by your own, because this LAN IP address is free when you have public IP. But public IP you will get from ISP. Okay. So here suppose ISP have given you public IP address from 12.0.0.0/30 range. Okay. And now we are going to enable our interface. So this serial 2 by 0 of your router 1 of company A is connecting to serial 2 by 0 of company B router 2. This is, but here switch interface and PC interfaces are not important. So you can remove. So you can remove as well. But these ports are important. The router ports and switches ports are important. Okay, router ports. Okay, switch one. It's okay here. Okay. Now we are going to start our lab. So you just click on start to start all your nodes. After starting, you have to click on this to have console access of all the devices here. So you can see here that you have your router 1, router 2 and your PCs. Okay. So once you have your two PCs and this is your network, which is your private network, private IP. Okay, okay. So from this private IP, inside in your LAN, you have three ports. One is router E0 by 0 is also part of LAN, and this 2 PC is also part of LAN. So you need three private IP address from this pool what you are using here, right? Okay. So when you are using this pool, so from this pool you need 3 IP for company B and 3 IP for your company A. So what IP you are going to assign? So I'm saying that, okay, for router E0 by 0 I'm using 192.168.10.10. Here I'll be using this, and here I'm using, for this computer I'm using 10.1, and for this computer I'm using 10.2 IP. Same here for here I'm using 20.10 for router 2 E0 by 0, and for PC3 I'm using 20.1 and here 20.2. Now we are going to configure all those IP addresses. So we are going to start from PC. So I'm going to configure PC1, which belongs to company A. So IP 192.168.10.1. Subnet mask is 255.255.255.0, and the default gateway is 192.168.10.10. Now you will say that, okay sir, I'm understanding this IP address of PC1. I understood that you are using this subnet. Okay, it's /29. So /29 will be 248. Okay, and now you are using here instead of /29 we should use /28. Here also /28. So if you are using /28, so the IP will be 240 as a subnet mask, and this is okay. So what is, I understood that okay, this is your IP address, this is your subnet mask, it's okay. But this is, what is this one? So this is the default gateway. Default gateway means what all computers of your LAN, whenever these computers wants to pass and try to communicate to another network, so these LAN computers will send data to your router E0 by 0, and your router will accept this when these computers are using this IP address as a default gateway on their computers. Okay, so you have to use this router IP address as a default gateway on these PC1, PC2, like that. Okay, so here I'm using the same like that, and then you can click save to save the IP configuration. Now let's come to your PC. IP 192.168.10.2 slash 28 and 192.168.10.10. See, you can assign IP address in both method in PC, but not in router. Router is different. Okay, so in PCC here, either you write like this, okay, or you should write like IP like this /28 or default gateway like that, and then click save. Now come to PC3, IP 192.168.20.1 /28, and the gateway is 20.10. PC4, IP 192.168.20.2/28, and gateway is 20.10. And now if you are coming to your PC1 and trying to communicate with PC3, which belongs to a different network, see PC1, when PC1 is trying to communicate with another computer in the same network, see, is directly communicating, no problem. But when PC1 is trying to communicate to another network computers like ping 192.168.20.1 or 2, whatever, see, you will receive some destination host unreachable or request timeout or not reachable, right? Why? Because see, when PC1 is sending some packets, so PC1 wants to communicate to these networks. So PC1 is sending packet to router, and router 1 is saying that okay, let me forward your packets to this network. But here router cannot forward any packets like that. Router will forward the packets based on its routing table. So let's come to router 1. Let's check that do router 1 know about that network. Okay, so before that, let's configure the IP address on router. So let's come here. Router has two interface E0 by 0, IP address 192.168.10.10, 240, no shut, then interface S2/0, IP address 12.1.1.1, no shut. So here we have configured the IP address on router 1. Let's come to router 2 to configure IP address. See, router 2 has two interface, so I'll come here conft int interface E0 by 0, IP address 192.168.20.10, and the subnet mask 240, and then here no shut. Okay, then interface serial 2/0, IP address 12.1.1.2, 252, and then no shut. And now you can save this configuration. Okay, so here I have saved the configuration. Now let's come again to our PC1. PC1 wanted to communicate to 20.1. PC1 is getting, PC1 is sending some data packet to router. Okay, so router is receiving, see, PC1 wanted to communicate, PC1 IP is 192.168.10.1. PC1 wanted to communicate to 192.168.20.1. Router is receiving the PC1 query, and router 1 is saying that I tried to send your packet, but that destination is unreachable from me, so the communication cannot be happen. Means you cannot communicate. That's why he's getting, PC1 is getting destination host unreachable message. But you will come to router 1 with that why router 1 is not able to communicate. So if you are checking router 1 routing table, so IP route, and you'll see that, see, router 1 know about 12 network and 192.168.10.0 network. Router 1 do not know about 20 network. So this 192.168.20.0 this network. So if router 1 do not know about this 20 networks, so router 1 cannot forward the packet. Okay. So what you as an administrator, what you have to configure, so router 1 could know about 20 network, and router can forward the packet from company A to company B, and company B router can also forward the packet to company A routers. So here we are configuring a static routing. Okay, static routing. Static routing. So for configuring a static routing, see, it's a very easy command, and see how you have to understand about a static routing. Now for a minute you can unmute yourself, and because here I'm going to ask some questions. Okay, because your intervention is important here, because I need that, I need to check whether you are with me or not. So as per this scenario, how many, first question, how many subnets, or you can say, or network we are using in this lab, or you can say scenario. First question. Yes, my friend. Yes. Yeah, Mr. Addy. Okay, so one, you are just sending message. I'm telling you to give me the answer. You are sending message. Okay, so here in this total scenario or lab, we are using three networks. So number one network. So you have to understand it. The first network we are using 192.168.10.0/28. Second network what we are using here, which is 192.168.12.1.1.0/30. And the third network what we are using here is 192.168.20.0/28. So here we are using three network. Okay, now tell me, router 1, if you are coming here, router 1 know about how many networks. So router 1, you can see here L means local to the router, and C means connected to the router. Okay, so it's the same thing. So router know about only two networks, router 1, 12 and 192.168.10. If you're coming to router 2, so router 2 know about two network, one is 12.1.1. and 192.168.20.0. So you can see here that you can write here R1 know about 192.168.10.0/28 and 192.12.1.1.0/30. Now if you are coming to router 2 know about 20.0 and this one, okay, but router 1 do not know about 192.168.20.0/28. Okay, router 1 don't know about this one, and router 1 do not know about 192.168.10.0/28. Okay. So as you know that static routing is the manual process, manual routing configuration. Okay, so with the help of a static routing you have to do manual routing, okay, here, and with the help of the static routing you will be configuring this. Okay, means after static routing, okay, this both network can communicate together with the help of static routing. Okay, so you have to configure it manually. So how you're going to configure it manually? So let's come here, come to router 1. Now you have to say conf t configuration mode, then you have to say here IP route. I want to add in my routing table 20.0 and the subnet of that network is 240, and whenever router 1 wants to send the packet, so what is your neighbor IP address? So you have to say that, okay, my neighbor IP address means router 1 neighbor is router 2, right? But whenever router 1 is sending some packets, right, any data, like some data one router 1 is sending to company B, so company B router 2 is receiving that data, but router 2 is receiving on which interface and what is the IP of that interface? So you have to add here in the routing table as a next hop. So you have to say here, okay, this is the routing 12.1.1.2, okay, which is the IP of my neighbor. Means neighbor is, who is the neighbor of router 1? Router 2 is the neighbor of router 1, and that is the IP, okay, of router 2 interface which is receiving the packets from router 1. Very simple command. Now let's come here and type exit and now check so IP route. Now you can see here static, S means static, okay, you can see here S means static. It's a manual configuration. Now router know about all these three network as per your scenario. Now router 2 don't know about that one, so same I have to do for router 2. IP route 192.168.10.0s 255.255.255.240, and the gateway for router 2 is router 2. Router 1 is the neighbor. So whenever router 2 is sending any packet, so router 1, this interface will receive the packet. So this is the IP address of the router 1 interface which is receiving the IP or data, you can say. It's 12.1.1.1. And now if you're checking so IP route, you can see yes, I have. Okay, so for a static routing or any type of routing, okay, so you have to match. If in your lab or in your scenario, if you are using 10 networks, so what is my network? So I have, this is my first network, let me change the color. This is my first network. Okay, this is my second network. Okay, and this is my third network. Okay, so now these are the three networks, and you have seen that yes, all those three networks are now with your routing table of router 1 and router 2. Okay, so now if you will come here to route PC1, and now if PC1 is trying to communicate to different networks, see, PC1 belongs to 10.1, right, a different network, and now you can see that PC1 is trying to communicate to PC3, which belongs to a different network, different company, like that, and see, they are easily communicating. Okay, and if you will come here to check whether they are is how they are communicating, so if you'll come here to router 1, and if you'll see that yes, how it is communicating, I think we can check with the trace here, trace 192.168.20.1. now you see router 1 is sending PC1 is sending packet to router 1, router 1 is sending packet to router 2, and router 2 is sending packets to his own network, which belongs to 20.1, and the destination, and it is communicating, right? You can see. So like, see how simple is your static routing. Okay, now the problem will come that, see, for a small lab, just when you have only two system, and this two system, or you can say that two company, and you have taken long time to configure, and but when you have like 5 or 6 router, okay, at that time you will have lots of problem. Okay, so now I'm going to take another little bit bigger lab than this one. Okay, to understand the like large network configuration with a static routing. Okay, so now here we have two routers, so now we are going to take another lab with three routers. Okay, static routing lab 2. So here we are going to take three routers. Okay, or you can say if you can take four routers as well, you can take it, no problem. So here one router, two router, and three routers connecting. So you can use serial also, serial 2 by 0, serial 1 by 1, and serial 2 by 2. Enable the ports 1 0 2 0 2, and now here we are going to take some switches. Okay, now again we are going to take some computers, four computer. Okay, so now we are going to start all this lab. Okay, and now we are going to put the IP address network. So here router 1, so 12.1.1.0/30. Okay. So here we are using this. Okay, and here we are using 23, and here we are using 13.1.1.0/30. Three links, three different networks, and now here we are using same LAN. So here we are using some IP address 192.168.10.0/28, same IP for our LAN. So you can say this is our LAN IP for LAN network. And this is for our WAN network. Oh, sorry, here also LAN, and here same IP what we are using. Okay, but these IP addresses what we have used here, this is our WAN IP, or you can say public IP. Okay, now here on this computer we are using 192.168.10.1, same like the last time. Here we are using 10.2, here we are using 20.1, and here we are using 20.2. And here on the interfaces, the router interface here we are using 10.10, and here we are using 20.10. And now let's take a console of these all routers and PCs. So let's come to a PC first. IP 192.168.10.1/28, and the gateway is 10.10. Save. PC2 IP 192.168.10.2/28, 10.10, and save. PC3 IP 192.168.10.20.1/28, PC4 IP 192.168.20.2. Okay. So IP configuration is completed on the computers. Now let's come to your router for configuring. So router 1 has 3 interface. So I'll come here conf t interface E0 by 0 IP address 192.168.10.10 240 and then no shut. Okay, then interface serial 2/0 IP address 12.1.1. Okay, so here we are configuring router 1 IP address. So router 1 has 3 interface. You can see that E0 by 0, okay, serial 2 by 0, and then serial 2 by 2. Okay, so we have configured only E0 by 0 IP. Now we are configuring serial 2/0 IP address. 252 no shut and then interface serial 2/2 IP address is 13 and then no shut. Save, and here you have command show IP interface brief exclude unassigned. So you can see here you have 3 IP addresses assigned on the interfaces. Fine. Now let's come to router 2. Router 2 has 2 interface. So conf t interface serial 2/0 IP address 12.1.1.2 252 no shut, then interface serial 2/1 IP address 24.1.1.1 no shut. Wanted to verify, so save and then type so IP interface brief exclude unassigned. Fine. See what we are checking here. We are checking IP address and the status of the interface up. Okay, now router 3. Same here, router 3 has 3 interface. Conf t interface serial 2/1 enter IP address. It's 24.1.1.1.2 no shut. Then interface 2/2. Okay, and the IP address is 13.2 no shut, and then last one is interface E0 by 0 IP address is 192.168.20.10 240 and then no shut. Save the configuration and check show IP interface brief exclude unassigned. Status is okay and the IP is okay. Now same, if PC1 belongs to a different network and trying to communicate to a different network 20.1 no communication. Okay, and if there is no communication, oh sorry, ping 192.168.20.1 no communication, destination host unreachable, same problem. Why? Because if you check the router routing table, so IP route, you will see that router 1 know about 12 network, 13 network and 192.168.10 network, which is directly connected to that router. See here, router 1 know about only 3 network, 192.168.10.10, 10.13, this one 192.168.10.0, 13.1110 and 12.1110. Router 1 do not know about this 192.168.20 network, right? Okay, so this is the problem. So what you have to do, you have to come to router 1. Okay, you have to say that to whom I want to communicate. So I want to communicate to 20 network, so you have to add that 20 network manually in your routing table, and you also know that how to add. Okay, let's come again to your router 1. Conf t, here IP route 192.168.20 dot
My route
20.0, and the subnet mask of that network 240. Okay, now tell me, router 1, when router 1 wants to communicate to this network which belongs to a different company network, this you can say here. Okay, okay, so here you can say this is company A and company. Okay. So when router or company A router wants to communicate to company B network, okay, so router 1 will send data to which router to forward or help to communicate. Router 1 can send data to router 2, or router 1 can send data to router 3. Yes, Mr. Amadou.
I talking to Miko.
Yeah,
I thought come again. I thought you were talking to the guys.
yes, yes. I'm asking question that if
Uh-huh.
router 1, which belongs to company A, wanted to
Yes.
communicate to, like, let me take a snap of this. Okay, suppose this is router 1, right?
Yes.
Okay, so when router 1 wants to forwards the data to try to communicate to this company B network, right? So
Yes.
router 1 will forward the data via R2 or via R3 to reach this network.
It will forward it straight to the R3.
Hmm?
To forward it straight to the R3.
Okay, it will forward straight to R3. Fine, no problem.
Yes.
Good, good. But the problem will come here, as you said. I understood. But the problem will come if this link will go down.
Yes.
What will happen? Do router 1 will be able to communicate to R3 network?
No, so you have to come and add it manually. Two of them.
Okay, yes. So what I have to do, when, as you know that static routing is a manual process,
Yes.
right?
Yes. Yes.
So when it is a manual process, so when you are adding this route, okay,
Yes.
so you have to add
You
this
have
route
add
as a
basically
backup path, right? So when
backup.
this
Yeah.
link will go down, no problem, your data can pass via this link, right?
Yes. Yes.
Okay,
Automatic. Yeah.
yes. So here you have to come to your router and you have to say yes, no problem. My first gateway is like this, you can decide.
Yes. Mhm.
Okay, this is my next hop router, and you can say yes. To communicate 20 network, you can also go via
Text.
12.1.1.2, right?
Yes.
Okay, now again come to your router 3. Okay, see, router
Yes.
1 configuration is completed. Now if you check here, so IP route, see, router 1 wants to reach 20 network. Yes, you have 20 network in your routing table, and you have defined
Yes.
the path. Now router
Yes.
3 conf t IP route okay, before that let's check your routing table. So IP route, see, you do not have 10 networks, so you should add 10 networks. So
Yes.
IP route 192.168 dot
Route
route 192.168.10.0 and the subnet is 240, and same here.
Yeah.
If we'll check this one, okay, for same router 3, when router 3 wants to reach company A network, so
Yes.
router 3 is directly connected to router 1,
Yes.
and if this link is down, so router 3 will add this
The
route,
second one,
yeah,
yes.
as a second link or second path to reach to
That's
that
okay.
network if there is a network failure or link failure. So you'll
Okay.
say, okay, no problem. For my first is this one, and my second is 24111. And now
Yes.
if you are checking, so IP route, see, is there? Okay. Now on router 2, if you are checking here, so IP route. Do I need to configure anything on router 2?
Yes.
Okay. Now if you will try to communicate, see, are you able to communicate?
No.
Why not? See, router 1, router 1 know about, if you are talking about previous example, okay, let's delete router 2. Okay, in the normal static routing, see, router 1 has configured about router 3,
Yes.
router 3 has also configured about router 1, okay, and the link is up,
Yes.
okay, and when router 1 is trying to communicate to this network and this network, okay, now see, ping 192.168.20.2,
20.
20.1, 20.2. No communication. Let's try from here. Ping
Okay.
192.168.20.2. Now, but if you're coming to router 1 and trying to ping from router 1, let's try to ping 192.168.20.10. Then there is some problem. Why? Now, if you're coming on router 2, see, conf t IP route 192.168.10.0, 255.255.255.240, 12.1.1.1, and 24.1.1.2 to reach 20. And now if you're coming on PC1, see, you're communicating, right?
Yes.
Now you tell me what was the problem. See, if I'm talking here, see, that's why I told you in a static routing, it is best for
Yes.
a small
Network.
network, right? But when you're talking about large network,
Like,
right, it could create a lot of
yes.
problems, and for finding the problems where the problem is, okay, you
Yes.
have to I mean, you can find the problem, but you should have a better knowledge of TCP/IP, okay, like
Okay.
where the packet is stuck. Now see, if I'm talking about normal lab, like if there is no router
Okay.
2, but see, router 1 directly connected to router 3, right,
Yes.
and router
Yes.
1 know about router 3 as a next hop, then why router 1 is not able to communicate? Now see, what was the problem in router 1? if you can check the routing table, right?
Okay.
See here. By default, router 1 was sending packet to this link directly.
Okay.
This one.
So
And
this is the
router
reason
2,
why
yes,
other
router 2
networks
was
drop.
not able to know about this network. That's why router 2 was dropping the packet.
Okay.
Okay. But now, once router 2 know about the router B network and router A network, now both can communicate. See here,
Okay.
PC3, if PC3 is trying to communicate, ping 192.168.10.2. They're communicating. 20 is
Yeah.
communicating to 10 and 10 is communicating to 20. Okay.
Okay.
Okay. But now one question will come in this lab, that you will say that, okay, sir, I want to make this path, the link has some speed Mbps, right? So you can say that,
Yes.
okay, sir, this one is 10 Mbps link. Are you understanding?
Yes.
This is a 10 Mbps link. This is also 10 Mbps link. But this link is 5 Mbps link. It is directly connected, but this is 5 Mbps link. Now tell me, when I will talk to you that, okay, let's make, redundant link, right?
Yes.
Redundant path or link for load balancing, or you can say for, if this link is down, for example, if this link is down,
Yes.
okay, if you'll say that, okay, oh, if this link is down, okay,
Okay.
so you have two options, okay.
Yeah.
If this link is down, so automatically your data will be forwarded from here, right?
Yeah.
But if this link is running, right, okay,
Yes.
so your data can be passed from here or it can pass from here, upper one or
Yeah.
maybe the lower one, right? The
Okay.
path is not defined by you. Your router can choose maybe upper path or lower path, right, for data forward. Okay, but you have to define that, no, 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 the upper link is the faster one. Please follow the upper link first as a path one. Are you understanding?
Yes.
You
Yes.
can say that, okay, let's make this
That's
primary path.
finally. Yep.
Okay, primary path is R1 to
Yes.
R3, sorry, R2 and then R3, right?
Yes.
Yes. And second, you can say secondary path, you can say R1,
Straight to R3.
yes, directly to R3, because the
Yes.
speed, if you consider the speed, see, we are
Yes.
not counting the hop, we are considering the speed.
This speed, yes.
Speed is here 10 Mbps and you are giving me 5 Mbps. So the upper one is best for me.
Yes.
Okay. So I'll consider the upper one as a best path. Okay. So
Yes.
when you are selecting these kind of primary and secondary, okay.
Yes.
So in this condition, so this is known as floating static route. Okay. So you can say redundant path link, primary,
Yes.
secondary, everything comes under floating static route. So this is also known as advanced static routing. The normal static routing is this one, what we have done. But now when we are talking about path manipulation, gateway
Yes.
manipulation, so manipulation is always advanced, right?
Yes.
So now let's make that one. So if you're coming here, R1, see, right now, when you have both path, so it will be like that, right?
Yes.
Okay. But now I will say that, see, if I'm on PC1, PC1 is saying trace 192.168.20.2. So PC1, see, PC1 is going to R1, then
Yes.
R2, then R3, right? Okay,
Yes.
now let's come to PC2, trace 3.1. Okay, this is also going via that one. Okay, okay, no problem. Clear cache. Clear, some option is coming. Clear ARP. Okay, now let's try. Okay, it's also going back. But as you can see that, see, if you will talk about hop count, right? Okay,
Yes.
so R1 is sending data to R3, right? But see, R1 is
Yeah.
coming to R1 one hop, two hop, then the data is coming, right? R1 is
Okay.
not considering this as a one hop, right? Are you
Yes.
understanding? So now what I'm saying, let's make this link as a 10 Mbps and this as a 5 Mbps. Okay,
Yes. I was a little bit confused about this one IP address in the
okay.
middle.
Which one? This one.
The 13 one, yeah. Over there I saw 24 that you configured. So
Where 24?
right now I saw it's 24 from R. Ah,
Where?
is yeah, this one 24.1.1.2.
Okay, 24 is this one. See,
Which one?
router. See, when PC2 is sending data, so the data is
Yes.
going to 10.10, right?
Yes.
Then 12.2, then 24.2, then data is going to computer, right? Now see,
Okay.
data is coming first here. Okay, data is coming first here. Let me show you. This one is sending to 10.10. Okay,
Yes.
10.10 is sending to 12.2. 12.2
Yes.
is sending to 24.2. 24.2 is sending to this one.
Okay. But here you put 23. This is the reason why I'm a little bit confused about that
Okay,
IP.
okay, okay, okay.
Uh,
It is 24.
okay.
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 So that's a mistyping. Okay. Okay.
Yes. Yes. Yes.
So now you can see that router 1 is sending packet to router 3 via R2, and the link is
Yes.
slow.
Yes.
Okay, and this link is high and it is 10 Mbps, but router 1 is not considering this link, right?
Okay.
Okay, so what I will say that I want to make this as a primary and secondary. So I want to make uh, so
R1 to R2.
R1 to R3 as a
Yes.
primary path, and secondary path I want to make as a R1 to R2 and then R3, right? Which is here is
Yes.
10 5 Mbps and here
Yes.
is 10 Mbps. Okay, fine.
Yes.
Now what I will do here, I'll come here. It's very simple configuration. Now you have to come to R1. See, you can see here two path, right? But now you
Yes.
have to
Yes.
say here, first you have to say
150.
so run section IP route. Okay. Now you have to copy this both. Okay. And you have to
Okay.
open notepad. For faster,
Okay.
you have to write no here and then you have to write no here. Copy,
Okay.
come here to your configuration and just paste this, right click and paste. The configuration is
Okay.
removed and now if you are checking so IP route, no routes, right? Okay.
Yes.
Now we are configuring the routes as a primary and secondary. So now see how
Okay.
to configure. Conf t. Okay. Now tell me this 12 one, this 12, I want to make it as
Yes.
a primary or secondary. 12 is router 2,
Secondary. Secondary.
secondary. So for him
Yeah.
is you just give him 10 or 20.
Okay.
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 Yes.
Okay. And now for 13 means router 3 IP. Okay.
Yes.
I want to make him as a primary or secondary. Primary. So for him you
Primary.
make 10. Okay. So the
Okay.
lower
Or
is
we can
better.
even leave it like this. The default one is how much? Is how many?
Default
10?
is 1.
Okay, so we can even leave it like this.
Yes,
right?
if even if I will leave like this default like this,
Yeah.
right, it will be considered
Yes.
as a primary.
Yes. Yes.
Okay, so what you want, I should I put number or I should leave it default?
Okay. You should put 10. I
Oh,
just want to make sure that when you leave like this,
okay,
it will
and now if you're
trigger.
checking the IP route, see, are you getting 12 information?
No. No.
No, because 13 is the primary one. And now if you're
Yes.
coming to PC1, and now if you're trying to trace, see, now PC1 is going via
Three. Taking.
directly with the help of 10 Mbps link, right? Now
Yeah.
the
Yeah.
PC2 is not passing via this link, right?
Yes.
Okay. And now what will happen? Suppose if you are pinging something like that, continuous pinging, for example,
Yes.
-C, like that, if your continuous pinging is going on, right? And
Yeah.
for example, if router 3, this link, the link which is
Yeah.
receiving the serial 2 by 0 is down, are you understanding?
Yes. Yes.
Conf t interface serial 2/2 shut.
Yes.
Now what do you think, the communication is stopped or communicating?
Just for a moment, and then it will choose the
Ye-
second part.
yes, let's see. Now if you're coming on R1 and now if you're checking the IP route, see, table is still there.
Yes. You can trace.
Uh, not this one, I think. Let's come to PC router 3. It's not like that. Conf t interface no shut, and now when this is communicating, now let's come to R1 and try to shut this interface which is connecting towards
Okay.
R3. This one,
To
serial 2.
S2.
Yes.
Yeah.
So interface serial 2/2
To
shut.
shut.
Request timeout. Okay. It should remove from routing table. Yeah, see, 12 is there, right? See,
Yes.
earlier it was 13, right?
Yeah.
But when the
Yes.
link is down, automatically the gateway is changed. And now so you can see
Okay.
PC2 is
Okay.
communicating, right?
Communicating.
Yes.
Yes.
So this is the benefit of these type of floating static routes, or when you have redundant path, right?
Okay.
And you can select manual. See, if I will not configure this floating static route, then your
Yes.
router can choose any path to reach to the destination. It will not consider
Yes.
any kind of Mbps or link speed. But as
Okay.
this is GNS, I understand. But in the real network, you have link speed, right? And your boss will
Okay.
say that, okay, consider this link as a primary and consider that link as a secondary. Then how you're going to select
Yes.
that one?
Okay.
Okay. So this is the best method in static. How you can
Okay.
select primary
The
paths
best.
and secondary path.
Yeah.
Okay. So
Okay.
yes. So we have completed our this static routing. Okay. So after that, we will be working with default and slowly API, GRP, OSPF, like that. Okay. So if you have any doubt regarding this, let me know. We will be working on that. Okay.